Hi everyone, welcome to our first online meetup. This will be one of the first online meetups in the series for knowledge sharing. The purpose is to share knowledge between our team members, of course, and for future community members who will be joining us in the future and will be interested to learn more in development in different parts of Webiny platform. Without further ado, I would like to invite our CTO, Pavel, to continue his talk for our first session. Pavel?
Hey there. Thank you, Albiona. Hey guys. Hey everyone. So the point of this meetup is to just start with our repository, so you know how to set it up, and introduce you to the structure of Webiny project and to describe our repository and how we approach development. So let's just jump. I'll share my screen, right? And my screen sharing is disabled. Sven. Yeah, there we go. Perfect. Thank you. To start, let's just jump over to our GitHub repository, and we work on master branch. So don't worry about switching branches. You'll be on master branch right away. And let's just take a quick look at the structure of our repository before we even begin cloning anything. So when you want to find some documents and guides to contributing, guides for our architecture, it will all be located in the docs folder. So just jump in there and you'll find tons of different documents. Some of them are related to the project setup for pull requests, issue templates, but there are a couple of important documents like architecture and concepts and contributing, where we outline the basic steps and details about contributing to Webiny as an open source project. So feel free to go through them at your own pace. It's all there. Besides that, there isn't much to mention right here. So let's just clone the repo and dive right into the code. I'm working on Windows, and I will not be using VSL. I'm using regular Git bash. I recommend you do the same. Basically, any terminal will work. So it's knowledge sharing. Any terminal will work except the default CMD. So don't try to run your project using CMD. That one is really not the best terminal for Webiny. Other than that, Git bash works great. Any Linux terminal works just fine, and VSL will also work okay, except it will be a little bit slower on performance. All right, once we cloned our repository, let's just go in, and the first step to do is, of course, install our dependencies. So just hit yarn. We are using yarn and not npm because our project is one huge monorepo, which means that we have a bunch of packages which can be published standalone. But for ease of maintenance, we organized it in a monorepo. Since we have like 70 plus of those packages, it would be a nightmare to switch between different repositories all the time. And Yarn has a built-in workspace support, and we use it in combination with Lerna. Usually when working with workspaces, people use npm plus Lerna. But if you compare Lerna to Yarn, Yarn is much faster with processing dependencies and hoisting packages. Lerna will do the job on smaller repositories just fine. But on our huge repo of over 70 packages, you can really see the difference in performance. So we just use Yarn to handle that, and then we use Lerna in our development workflow and publishing packages to npm. There are some cool resources on the internet. You can see the comparison between different tools and combination of those tools. I will link the article later on. It contains all the benchmarks using npm with Lerna, Yarn with Lerna, and all sorts of different metrics and benchmarks. It's a nice little article if you want to dive really deep into how to handle monorepos. You can see a lot of output and warnings. You can safely ignore these, as you can see those warnings are coming from deep dependencies which we don't have control over, so just ignore them. So yeah, the first installation will take some time, and just bear with it. So our repository contains different kinds of packages, like for API, for React, utility packages, serverless components. So once you set up this repository, you have your entire Webiny project in one place, and that's how we develop, and that's how we publish it. So you don't have to switch repositories or search for other resources anywhere. It's all in this one huge monorepo, and this first installation can look scary, but it's like you do it once and you're good. If you do it with VSL terminal, it can take a lot more time than this, since VSL is using mounts, like it's mounting Windows file system onto its internal Ubuntu. So it will take a lot longer than this. You do get a nicer terminal for sure, but you do sacrifice the time. Almost there. Right. Like if you just take a look at these binaries it's compiling, and you see this Mongodb memory server, we are using different tools to test our code, and to avoid connecting to an actual MongoDB server, we are spinning up this in-memory tool, which is it just boots an in-memory MongoDB, runs the test, destroys it. So that's why we have all kinds of utilities. All right. So you're kind of there, but there are other things you need to do before you can actually open this in your IDE and start coding or doing something. So the first thing we just did is we installed all our dependencies. Now we need to prepare our repository for development. And I will just run the command. It's in the contributing guide. So it's yarn setup repo. There we go. What this does is it generates some environment JSON files, which are local to your project, to your machine. You don't commit, you don't push these to a repository. They're only for your local development, but you do need them. So these files are generated, and then what we're doing is the second longest process is building all packages. So what this does is it takes each package we have in our repository, and like 90% of our packages are written in Typescript. So we need to build and transpile all the code to make to convert it into a usable NPM package. And once this is done, I'll show you why this is important. So this can take a lot longer on VSL terminals. I just can't stress it enough. We have had a lot of inquiries about VSL. It does work perfectly fine. It's just the performance that's a little bit slower. So this process is performed by Lerna. And what it does is it analyzes all packages, all its dependencies, builds a dependency graph. And there is a particular order in which these packages are built. It's not random. So first, Lerna builds all those packages that don't have other dependencies. And then it descends into the next level of dependencies and builds those, and so on. It's important because TypeScript declarations defined in one package are used by TypeScript declarations in other packages. So it's in the order of building is very important. That's why we just leave these to Lerna, let it figure out the order and build this however necessary. This is
For
one
the,
of those.
sorry, I have a quick
go
question.
ahead.
For the sake of somebody coming in, why did we go with TypeScript for 90% of our packages?
You mean like why not the 100%? Oh. Yeah.
Well, maybe like why the lean towards TypeScript instead of JavaScript, for example.
Yeah, well, with TypeScript you get a much more discoverable code, so it's much easier for somebody who doesn't know how to use your package to just use autocomplete that TypeScript provides you. Plus, like the main reason for TypeScript is its checks for variables and methods and parameters and stuff like that. It just helps you code faster and safer code. Whenever you define something that doesn't exist or use a method with the wrong method signature, it will yell at you and it will immediately know that something is wrong and quickly fix it and you're done. And when we have 70 packages, it really helps knowing that when I run my code, it will, like 90% it will work. Of course, you can't avoid some logical errors. That's up to a developer, but stuff like classes, functions, methods, variables, and invocations, that's where TypeScript shines. It really helps you use the code in a way that was meant to be. Plus, since we have a huge amount of plugins, which are just plain objects, TypeScript is the only way you can easily use those plugins and know exactly what to implement because you have autocomplete on those. So now that we are done building, I'll jump into my IDE and show you what's the result of this whole setup procedure. It will open my current project. I'll just switch to our new knowledge sharing. Let's see, where are you? Anywhere? Knowledge sharing. Come on. Where is it? This is fun. So Webiny. Am I looking at the wrong path? No, the Webiny knowledge sharing should be here. Where is it? I can't see it. Oh, this is here. Oh, there it goes. Yeah, this window. All right. So this is what you have now after this long process of setup. So I think the most important thing to know about the repository is that all the packages are in packages folder. And here you can see like over 70 packages. They're all in here. And there is also this little folder called sample project, which is your sandbox for development. It shows you the structure of a project that our users who set up the project via Create Webiny project tool, you'll get to that later, but their project will look like this. And with this, we just simulate user's project within our repository. So now let's just take a quick look at what's happening when you build packages and why we need building, what's TypeScript and how it helps and how it links things together. I'll just open the first package. It doesn't matter which one. Let's just take a look at this one. So when we write code, we write it in the src folder and we write it in TypeScript. But when we use the code, we can't use TypeScript without building it. So we have these config files for TypeScript, and I'll explain why we have two of them. So the tsconfig.json is the default TypeScript config file, but we have two use cases for TypeScript here. So one is the check for types during development. So in your IDE, for example, you're doing something in the code, your IDE will automatically pick up the tsconfig JSON file and use that one. And you don't want to emit type declarations. So for these configurations, type declaration emit is disabled. So basically, all the type checks are performed at runtime. We won't go in very deep into that. Just know that you need to have two config files. One is for type checking during development, and the build file is when you actually build your package. And we'll have a deeper look at that later on. It's not that important at this point. So you'll notice the dist folder. Dist folder is where our actual compiled code lives, and it contains everything that is ready to be published to NPM right away. Like we could literally just run npm publish within the dist folder right now, and this is the code that anybody can download and use. Since we have these source and dist folders, we have a little problem here with monorepos. So Yarn links packages as workspaces. So for Yarn, each of these packages are separate workspaces. Now, the problem with Yarn is that it links packages to their root folders. I'll show you in a second how it looks in node modules. But the main problem is that the links to these packages will point to exactly this folder, like API cookie policy. And if you want to import code from here, you would have to literally point your code to /dist/something. That's not really helpful. That's not how we want our users to use the code, especially not when installed from npm. So I have this little tool. You will notice when you run, let me open package.json, I'll show you how it works. I'll just close this. So we have this post install hook, which is a built-in npm and Yarn hook. It always gets processed after you run npm or Yarn. So in this hook, we run a little tool we created to really improve handling of packages in monorepo, especially since we have source and dist folders. What this tool does, is it links workspaces to the correct folder where compiled code lives. So not the source code and not the root folder of the package, but the compiled code. And if you go to Webiny scope, you will see that here are all our packages. You will notice a little link icon in the corner of this folder. And if you open it, you'll see that it's actually showing us the content of the dist folder. Magic. This is very useful and helpful because you can now safely import or require this package anywhere in the project, and it will always resolve to the correct built JavaScript, as if you installed it via regular npm. So let me show you what happens if we don't run that special utility of ours. And that's the only difference between how we handle monorepos and how other projects handle it. But we found it really necessary to avoid lots of transpiling and like weird webpack configs and stuff like that. So we have this little utility in our project URLs. I'll just jump straight to the code. I'll change one little thing. You don't need to know what I'm doing. I just want to show you what would happen if we didn't have this. So I want packages. Basically, what I'm doing is I'm just disabling all this logic of linking with correct destination. I'm just running that script again. So it links as if it was Yarn. And let's go back to node modules and see what we get in our folders. See, so now it's linking to the root of each package. And this is totally messed up. So we have source and dist here. And this is what you get when you just use yarn out of the box, and it's not really useful for us. See, we have to go deep into the dist folder to import anything. This is not good. So this little tool just links packages to the dist folder, or better to say, to whatever you configure your package to be. So each package has its own package JSON, because each workspace is considered a separate NPM package, right? So if you go in package JSON file of each of these packages, you will see there is this publish config, which is an NPM object that with which you configure access to your package. But then you will notice there is this little directory config parameter. And this is not something that's built into NPM. This is something Lerna uses for publishing purposes. So with this, you basically tell Lerna, hey, when I run a publish process, publish to NPM whatever is located within this folder. That's great. That works fine. But for us, I also added that package linking to work using this exact option here. So with this, you tell our little script, hey, this folder is where my compiled code is, and that's where you should link it to. There are other packages that don't have this because they don't use TypeScript. For example, our serverless components don't use TypeScript. And if you go there, you will see there's just code right there. There is no src folder, no need for it. And if you go to its package JSON, you will just see directory points to this exact directory where the package JSON is located. So our tool will not try to link with any subfolders, but with this exact folder. This is like the only thing that is tricky about the setup of our repository. And once you know that this exists, you basically know everything about how stuff is linked in here. There is no more magic, and all your packages are linked correctly in node modules and can be used as if you installed them via npm. The only important thing for development is that whenever you change something in any of these packages in the src, you need to run build of this package, so it compiles the code and puts it in the dist, and then your project is pulling the latest code from there. This is like the only catch in here. So now that we have our project, it's almost ready to be deployed, and to begin any kind of development, we need to deploy an instance of an API for React apps to talk to, and to do that, we need a connection to our database. And you will see that we have these environment.json files generated for us. And the last thing to do is just to replace this with your Mongo database connection string. We usually use MongoDB Atlas to do all our development. And if you don't already have your Atlas set up, there is a guide in the documentation, and it's also linked to the contributing guide, so you can quickly go through that and get your connection string. I will just grab mine from a previous project. Let me just quickly do that. Sorry. Yeah, it's thinking. Just give it a second. So when we ran that setup repo script at the very beginning, it generated these env files for us based on these example files here. Knowledge sharing. This will be the name of our database. And now we are ready to kick off the deploy process. Our packages are built, everything is linked correctly. So the next step is to deploy our API. So sample project is a folder that's considered to be the user's project, right? So to run any commands with Webiny CLI to deploy anything, you need to go into that project, and that project is considered to be a project root. Project root always has this webiny.root.js file, which contains different plugins and your project name, stuff like that. We will go deeper into this later on. It's not important at this stage. Let me just rename this project name into knowledge sharing. This project name is important because it will be part of all AWS resources when you deploy. Okay, now that we are in sample project, first let me tell you one little trick here. For some reason, Yarn will not resolve your Webiny correctly, your Webiny CLI. So within our repository, you need to use npx select right, npx Webiny. Then you can run help to see all the available commands in the CLI. And the one we care about is deploy. We will see how we use other commands later on. It's not important at this point. So let's do this npx Webiny deploy, and then I'll stop here for a second. So these API and apps, these folder names are not important. Like the concept behind them is these folders are what we call stacks, and you can create more stacks within your project. If you have several different APIs, you can just create a new stack. So literally just a folder which contains resources.js. We'll get to that later. So this is one stack, this is another stack. You can create as many stacks as you want, and you can name them whatever you like. These are not like system keywords or something. It's totally up to you how you name these. So you just, in your deploy command, you just point to a folder, whatever it is. And then we need to specify an environment we're deploying. So for local development with React, which starts a local Webpack dev server, we need a local API environment. It sounds weird, but I'll explain it in a second. Let's just use the time and run the deploy. So it will take about 3 minutes to deploy everything. And I will use that time to explain what's going on. So to develop your local React apps, your apps need to talk to some kind of an API. And since Webiny is a serverless platform and is oriented towards cloud providers, we do not support, at least at this point, we do not support any kind of local simulation or local API development. Everything has to be deployed to AWS account, and those are real lambdas you will be hitting, and real CDN, API gateway, S3 bucket. All that will be used instead of doing some kind of simulations. That's why we need this local environment. Like local is, I think, the only actual like built-in system keyword that's important because we need to. It sounds funny, but we need to deploy a local API, which is like when you pronounce it, it sounds totally funny. But what it means, it's just deploying an instance of API with all of the infrastructure, and we will use it for local development of our React apps. That's all there is to it. So right now it's just reading this resources.js file and is deploying the infrastructure, which is defined in here. So it deployed Lambda role, and we use this component to create the role. Then it is deploying Apollo gateway, which is a Lambda function, which serves as an API entry point, and so on. So the order of these is, of course, not important. The deploy process will build a dependency graph as well, just like Lerna does, and will deploy your resources in a specific order. So you can see the entire stack definition in here. So this resources.js file is the only thing that's mandatory for your stack to work. Other than that, you can do whatever you want in here. So the file organization is totally up to to the developer. This file is the only thing that's important. And a little note on the deployment process: it's not hard-coded into anything. Like we don't force you to use our way of deploying. This is just what we provide out of the box, so you can get started quickly and deploy your resources as fast as possible. It did spend quite some time to optimize the deployment time, and we were about 30 to 40 seconds away from being done with the whole deployment. The deploy process is a simple, well, not so simple, but it is a plugin to the CLI, and it's defined in the Webiny root.js. You can see this require, and then CLI plugin deploy components. We'll dive into this deeper later on in another session, but this is the plugin that is responsible for doing all this magic with deployment and removal of resources. All right. So once you're done deploying, you get this neat little output, which tells you where your main GraphQL API is located. And since we also have a headless CMS configured, which has its own entry point, you have all these printed in here. The only thing at this point we care about is the main GraphQL API. It will take a couple of minutes for it to become available. Like for me, it's usually 3 to 4 minutes, but sometimes it can take up to 10, 15, depending where you're located, how far the data center is, and stuff like that. So just give it a couple of minutes to become alive. I will open this link so I can show you what you can expect. So right now it's dead. There's nothing to see here, and I'll split the screen so it's easier to show you stuff. So what happened? We did complete a deploy, and now what? What's happening in the background? What did we do? You will notice that in this project root, you will have .webiny folder. This is what we call a state storage folder, and you will see that there is an exact same stack name as we deployed. So when you deploy a stack, its state will be stored into exact same folder name. So we deployed API stack. This is its state storage folder, and inside there, each state will be grouped in an environment folder. So we deployed an API stack for a local environment. We get these folders in here. If you open them, you will see tons of JSON files, which contain the actual data about AWS resources that were created. Our components that deploy this using AWS SDK, they control what is stored in each of these files. So with time, we may reduce the amount of output. Not all of it is really important. But if you get lost in URLs and different CDN URLs, API gateways and stuff, this is the place where you can find all the data about your infrastructure in one place. And there we go. You see, like my CDN took, 2 minutes, and it became accessible, and we have our GraphQL playground. So what's this? So this playground is a playground for GraphQL, where you can see the whole main API for Webiny for all the installed apps. This is the API that is used by our admin app mostly, but also for rendering of sites and forms and authentication and stuff like that. And here you can just click through all this and see what's available and write your queries if you're authenticated. Some fields are even public. But when you see this, you know your API is working, and you can now move on to starting your administration app. So why do we need to start an admin app? We need to start it because we need to complete an installation wizard, which will finish the setup of your API. It will also install some demo data, set up your user, and stuff like that. So now we need to open our terminal again. And like if you're using git bash and storm, it will sometimes just erase all the history above. So you lose your API endpoints and stuff like that. If you really need to see them again, there is no really clear way at this point. You can either run the deploy process again and it will print again, or you can consult those state files and figure out what your CDN URLs are. So at this point, let's just navigate to, wait a moment, where am I? Sample project, right, so apps. Let's navigate to apps, admin, and just hit yarn start. It will begin the build process. And right now, how this works is when API is deployed, at the end of the deploy, it triggers some hooks to inject data about API URLs, Cognito user pools, and stuff like that. It's injected in your apps environment JSON. If you look at it, you will see this is the local environment we deployed, and this is all the data that is required for successful React app build and usage. So these are injected automatically, and we even have some ideas how to eliminate this altogether. But right now, this works in a way that you deploy an API, it injects some data in here, and this data is used by Webpack when bundling your app. And that's how you tell your React app where your API is. All right, I will just drag the browser back in here so you can see the whole thing. So now you just go to your local host, and it will open automatically for you. And here we are. We have our installation wizard. And the first thing to do is to create your username. Since we have an empty Cognito user pool, which we just deployed, we need to create our first user to be like the super admin account. I usually just leave it like admin@webiny.com. You can, and you don't have to subscribe to our newsletter. This is more like for our users, not developers. So I'll just leave it blank. When we click install security, what's happening is this module is communicating with first with our GraphQL API, which in turn talks to Cognito and creates this first user. And it installs it in both our database and into a Cognito user pool. Now I just need to log in to confirm my credentials. And once I'm in, okay, we can continue with the installation process. Some of these install steps are automatic because they don't expect any input from the user. Like this file manager that you just saw, it just went through it and installed itself. Like, for example, for locales, you can pick which locale you want. That's why we have to actually confirm it. Let's just go with the default. Hit install, and now the page builder. Now this step is a little bit tricky, so let's just enter it. Knowledge sharing. Nice. Now this input, just for now, I won't go deep into this. Just enter 3000, and later on we'll see why it's important. Because we will run our site app, the app that actually runs like the site for users, for visitors. It will be run on port 3000. So just bear with me on this. Just enter 3000 and hit install. This page builder installer is a little bit more complicated. It creates some demo pages. It uploads lots of files onto S3, creates some page blocks, page categories, and stuff like that. And this is all done via plugins. So whatever you see on this screen, each of these installers are actually plugins. And they have a matching set of like React plugins plus API side plugins. And this is how you create new installers for your apps. Everything is pluginable. And let's just finish this one. Yeah, we are done. Cool, let's just open the administration. And here we are. I'll just make this a little bit more narrow like this. Yeah. So here you get to a welcome screen, and you get some useful links, how to start with each app, links to documentation, code examples, our social accounts. And this is the skeleton for further development. In the menu, you have all the apps we currently provide. They're all enabled. Everything is here. And this is where you start your React development. So I just want to talk a little bit about how to approach like developing something new or even modifying an existing package, and how to set up your development workflow in a way that you don't have to manually rebuild and rerun all these Webpack watchers and stuff like that. So I will move the screen away, and let's go back to our repository. So for example, let's take a look at this welcome screen. This is a great example. Let's just make a simple change. Let's just change this hi message. I will remove the browser and just guide you through the process quickly, so you know how to approach your future development. So I'm not really sure which package that welcome screen is. I'll just search for, yeah, welcome. Oh, it's a plugin, right? All right. We did it as a package with a plugin of its own. There's lots of styles. You get started. Right, here we are. So this is hi. The code is not important at this point. What's important is how do you run watch on packages you want to work on, and how to trigger Webpack rebuild on your React app. So basically, you only need one thing, and go back to our repository root, and we will use Lerna to watch for changes in packages we are working on. So for this example, we want to watch the app plugin admin welcome screen package. And whenever we change something in that package, we want it to automatically build from source to dist folder. And that will trigger our React app to automatically rebuild. So let's do Lerna run watch. So why watch? Where does this come from? If you open up a package JSON in each of these packages, you will see it has a watch script, which it just transpiles code with bubble and strips away all the TypeScript. At this point, it doesn't use TypeScript compiler, so you can see DSC is only used when you run build. So in watch mode, TypeScript checks are performed by your IDE, and the watch process is extremely fast. It doesn't care about TypeScript. It just transpiles your TypeScript files into plain JavaScript. So we do Lerna run watch, and then we use scope. You can read more about this on Lerna docs. There's a link in the contributing guide. So we literally specify the name of the package as specified in the package JSON itself. So let's do app plugin admin welcome screen. And the good thing to do is to add the stream parameter, so it streams all the output from this command to your terminal, so you see what's going on. So app plugin admin welcome screen stream. When you run this, Lerna will match those the scope parameter. You can also specify multiple scopes if you want to watch multiple packages. And it says, hey, I found this package. This is what I will run the watch command on, and it stays in this mode. It doesn't exit the process. It just waits for changes. And this is like the only thing you need to do to have that fluid development cycle. The other thing is First, always run Lerna watch on your packages, then start your React apps. Otherwise, the Webpack can go crazy because you will be rebuilding your app like 10 times a second, and sometimes it just it blows his mind. So first start your Lerna watchers, then go to your app and run the local development. So sample project, apps, admin, and now we do yarn start. It will build our admin app again. And I will cram this in one screen so you can see what's happening. This. And once it's done, we will do a change somewhere here in React. The code itself is actually located in the packages, in the actual source folder. But you will see how it all ties in nicely together, and you get a really nice flow. So we're done here. I'll refresh it. And then I'll switch back to our watch terminal so we can see what's happening. So you see both things. Let's change hi to hey. Just save this file. Once it's saved, you see, it recompiled the file, and Webpack picked up the change from node modules. And you're done. And this is the way to develop. Same thing goes for developing the API packages. It doesn't matter that you use React and Webpack Dev Server here, and for API deployments you don't. Actually, you do use Webpack, so we can have those watch. But this basic Lerna run watch command applies to all packages in the repository. So use that. I'll show you also how to run watch on multiple scopes. There is one extra parameter to keep in mind. So let's add what could be a good candidate for this. I don't know. Let's say you want to change this page builder widget. It's a plugin itself, and this plugin is located in app page builder package. So I will just add that package here, page builder. If you run it like this, Lerna will only run watch on this one scope and will completely ignore the second one. And for that, you need to run the command using this parallel parameter. What this does, it tells Lerna, don't build the dependency graph, just run this watch command on all the specified packages, no matter the dependency. So if one package depends on the other, it doesn't care. This parameter is, however, dangerous when you want to build packages, because there the order of building is really important, and that's why you don't want to use parallel when you're building packages which runs Typescript compilation. That you don't want to do. This is only necessary for these watch runs. Let's do that. And I will go to app page builder. Let's figure out where this plugin is. Oh, welcome screen widget, right? Easy to find. And we have this. In here. You can see build a new page button. And let's see, what can we change? Let's change this build a new page. Let's say create a page. And when we save this, we had our watch, it rebuilt the code, our Webpack figured out there's something new, rebuilt, and we have our create a page, and we have our hey Paul. And now I'll just jump over to another package, and I'll undo my change of hi, and you can see I don't even have to save anything, it's so fast. Done. So this is your development flow. You just add everything you're working on to watch, and the transpilation will be taken care of for you. Yeah, this can happen sometimes. It has to do with the API. Just refresh the app, no big deal. And yeah, basically this is the process. There we go. we are back to high, and just for the sake of the example, let's return back with this build, and we are done. You don't have to restart anything unless you're adding new scopes to your watch command. In that case, it's best to just stop the command, stop your app, run Lerna watch, then run yarn start on the app you're working on. And this is it. This is basically the flow we are using on a daily basis. This is how stuff works. And let's try a little thing with our API. Currently, we don't have any kind of a token to access our API, but some things are public. So let's try with the page builder. By default, our installer installs some demo pages for you to not have an empty site. So let's go into list published pages and get some data from it. There you go. This is your API deployed and working. Just quickly add and build queries, test them here. And in your docs, you can see, you can actually filter stuff like list, published pages, and you quickly get to the exact types you're looking for, see what they return, what arguments they accept, and stuff like that. Any questions, guys, so far? You're all so quiet. What else can we talk about?
So one of the questions I have is, or maybe just a clarification for newer folks, is the fact that there are those 3 different links for your API URL. So the first one that you showed right before that you were just looking at, the playground, that's for, I guess, one subset of information. And that's more, I believe, on the admin side. But maybe you can clarify on why someone would use, what would someone use a one URL for versus the other, and then maybe go into how the development process might go into using them, basically, more or less.
Yeah. So the main GraphQL API is the core of Webiny API. It contains stuff for management and creation of data, and mostly we are working with that API. Like whatever new features we develop, we usually build on top of that. The other 2 links, I just ran a build again just so we get that output, so our viewers know what we're talking about. So the other 2 links are related to our CMS exclusively, and we wanted to separate our main GraphQL API from CMS API so we don't clutter the GraphQL schema and have separate entry points for different environments, different aliases. Those URLs, they'll show up in a minute, they are used for accessing the data in our content management system and for managing data in content management system. They are structured like under the hood. Those 2 APIs work a little bit differently. So the main GraphQL API works as an Apollo federated API. It means that it is constructed using smaller GraphQL schemas and microservices, while the CMS API, here we got the output, so you can see it down here. So this main GraphQL API uses Apollo federation to construct one huge schema from smaller schemas, which are located on, each schema is located on a separate lambda, and then it all gets aggregated at runtime, and that's how you get all that, like the one huge complex API. And then the other 2 URLs, like these read and preview, they are related to CMS exclusively, and they do not use federated schema, but a simple Apollo server and build and serve their schema directly. Both of these APIs are they are not connected in any way. In our admin app, when we use CMS and we need to create data, we talk to these endpoints, and there is a third one to manage. So there is a read, and there is also a manage endpoint. What this means is, for example, if you're building a Gatsby site and you just want to get data, you will be using this CMS read and then the name of the alias to get data from environment you want. And this means that that particular endpoint is only for fetching data. It will not allow you to do any mutations on the data. It's like read only. That's why it's called read, literally read only. Now, preview endpoint is to build a preview version of your site using data that is not yet published. So your content editors may create data, and you're not sure you already want to rebuild your site with that particular data. You just want to build a preview and see how it looks like. Then you would use this preview endpoint. It exposes data that is in the system but is not yet published. And then there is, yeah.
If somebody is creating, let's say, something, they just create a group or a model or something, and they want to preview it without publishing, do they actually have to write the GraphQL endpoint themselves, or is that auto-generated?
You get that by simply visiting this URL. Let's open the preview URL, and you get your playground. And here you can discover your CMS API by either going to docs and just seeing your queries, or literally typing a query in there. Currently, we don't have any content models created, so there isn't much to query. But if you did have some data, it would be here. It would be generated, and you will be able to see it in the actual documentation. So whenever you add new content model in the admin app, it will automatically refresh this by visiting this URL, right? It will not automatically refresh it, but by revisiting this URL, it will refetch the updated schema, and that's what you will see here. Same works for read, preview, and manage endpoints. So they all get refreshed whenever data structure changes. That's what, and this is the way to experiment and play with it. You just open a GraphQL playground at that URL and experiment. If you need to attach authorization headers, you do it via this little box down here, like headers. But I wouldn't go that deep at this point because this is more related to how you use a CMS, which is not really that important at this point. Yeah. I wanted to talk a little bit about how this gets deployed. So what is this? What's all this output? Because you guys see this like every day. You look at it the entire day, and then we never actually talked about it a lot. So let's see what's happening when you run a deploy command. So as I mentioned, we have a built-in mechanism for deployments. And what it does is it opens this resources.js file. It reads these resources. And it also reads this state. So it reads this, all this. If you open this one file, it's called webiny.json. It will contain the state for your entire infrastructure in one file. Then it gets broken down into separate files, but this one file, it contains everything. And you can clearly see, like, this is the output of our database proxy. This is an output of our Cognito resource, and so on. So what happens during deploy is these two files are parsed, and we build a dependency graph between resources. And that way we decide which resource gets deployed first. So the one that doesn't have any dependencies will be deployed first. What does it mean doesn't have a dependency? Like, this is a good example right here in front of us. So you can see Apollo Gateway, and it has a role. And then this role uses this weird syntax, which means reference my Lambda role and get its ARN. And this basically defines a dependency on Lambda role. So we can't get anything from another resource until it's deployed. And this is how we build the whole dependency tree. We figure out which resource needs to be deployed first, then we satisfy dependencies for other resources, and so on. So it's like one huge tree we have to traverse and figure out the order of deployment. These components, you can see them, they're defined in component key for each resource. So when I say resource, I mean this. Whatever has this unique name and then a configuration, this is what I call a resource. And then this is another resource. And then database proxy is a resource on its own. Why resource? Because it creates a piece of infrastructure on your cloud provider. For now, it's AWS. And each of these will be deployed as a small unit, which is mostly standalone, but using these dependencies, we could say they depend on each other. But from AWS point of view, these are really separate resources. And let's take a look at something that deploys code. Like, for example, AWS role doesn't deploy code. We just use AWS SDK, we create a role, done. But then we get to deploying the code. Code needs to be built. And how do we do that? So each resource has these three sections. So we have watch, build, and deploy section. Watch is something I'll show you a little bit later. It's somewhat similar to how you develop your React apps, but the Webpack for React app knows how to watch itself. Let's put it that way. And since the deploy process is like something that is run once, and once it's completed, it just quits, like I'm done. We had to introduce this mechanism of watching specific folders and rebuilding and redeploying resources during development. It saves you some time from going into terminal each time you make a change in the code. It will watch the changes and redeploy. The other very important thing is this build section. So build section tells our deploy process, hey, this is the root folder I want you to switch to. It literally just changes the current working directory. And then in that directory, run this script. So these scripts are, how would I say, these are created by developers. You can modify them, you can do whatever you want with this. If you have a different way of building your package, you would just change the command here. So our deploy process doesn't care. What he'll do, he'll just switch to the folder, run this script. When it's done, it will continue to deploy. And now deploy is interesting. Deploy uses this component. The component is actually an NPM package. And it loads the package and gives it some input. And this is the input for this component. How it looks in code, since these packages are in our repository, you can just look at them, look at the actual code. So ignore the scope. All of the packages in our repository have this Webiny scope. And just look for this part in your packages, and you will see serverless function. There we go. And this is what gets loaded. And the default method is executed for deploy using the input you provided. So let me just split this view. I'll be able to show it a little bit. clearer. So this resource, right, it will load this component, and then it will, these inputs mean these inputs.